Have you ever wondered what makes the sun, our nearest star, so powerful and mysterious? This fiery orb, the cornerstone of our solar system, is more than just a bright beacon in the sky. It's a celestial titan, a crucible of nuclear fusion, and a generator of life-sustaining energy. The sun's structure is a marvel of cosmic architecture. At its heart lies the core, a seething cauldron where hydrogen atoms fuse together to create helium in a process called nuclear fusion. This fusion releases a tremendous amount of energy, which slowly makes its way outward from the core. Beyond the core, we find the radiative zone. Here, energy bounces around in a celestial game of pinball, taking about 100,000 years to traverse this layer. Following this, the energy enters the convection zone, where hot gases rise and cool gases sink, much like boiling water in a pot. Next on our journey, we reach the photosphere, the visible surface of the sun. This is where the light we see originates. Above the photosphere lies the chromosphere, a layer that emits a reddish glow, best seen during a solar eclipse. Finally, we arrive at the sun's outermost layer, the corona. Mysteriously hotter than the layers beneath it, the corona is home to breathtaking solar flares and coronal mass ejections. It reaches temperatures of over 1,000,000 degrees and extends millions of miles into space. The sun, a ball of hot, glowing gases, is more than just a bright light in the sky. It's a celestial body with many mysteries yet to be explored. As we delve deeper into the sun's untamed realm, we continue to uncover new and fascinating insights about our nearest star. So buckle up as we journey into the heart of our solar system and unravel the mysteries of the sun. Did you know that the sun has an incredibly strong magnetic field, far more potent than Earth's? Yes, you heard it right. The sun's magnetic field is mind-bogglingly powerful. It's a force to be reckoned with, and it's responsible for some of the sun's most captivating phenomena. You see, the sun's magnetic field isn't like Earth's. It's not a simple dipole with a north and a south. No, it's a complex, intricate tapestry woven by the sun's turbulent, churning plasma. This plasma, in constant motion, generates electric currents, which in turn create the magnetic fields. It's a bit like a dynamo, a self-sustaining generator of magnetic energy. Now, imagine this magnetic field as an intense, invisible force field extending millions of miles into space. It's constantly changing, twisting, and turning, and every 11 years or so, something fascinating happens. The sun's magnetic field flips. The north becomes the south, and the south becomes the north. This cycle is linked to the frequency of sunspots and other solar activity, and it's a crucial part of understanding our sun. But what's truly awe-inspiring is how these magnetic fields interact with the sun's plasma. When magnetic field lines become twisted and tangled, they can suddenly snap and reconnect, releasing vast amounts of energy. This process, known as magnetic reconnection, is what powers solar flares, some of the most explosive events in our solar system. These solar flares can have a significant impact on Earth. They can cause geomagnetic storms, disrupt satellite communications, and even create spectacular light shows in our night sky known as auroras. But don't worry, our Earth's magnetic field does a great job protecting us from most of this solar radiation. In essence, the sun's magnetic fields are not just a scientific curiosity, they're a fundamental aspect of our sun, and they play a crucial role in shaping our solar system. So next time you look up at the sky, remember, there's a lot more going on than meets the eye. Solar flares, powered by the sun's magnetic fields, are one of the most breathtaking celestial events to witness. So, stay curious, keep exploring, and let's continue this captivating journey into the mysteries of our sun. Have you ever heard about sunspots and wondered what they are? Let's dive into this fascinating subject. Sunspots are dark, cooler areas on the sun's surface. They're like solar blemishes, triggered by the sun's magnetic field. Imagine having a magnet so powerful that it causes visible distortions on your skin. That's what happens with the sun. These sunspots aren't just fascinating to look at, they play a vital role in the solar cycle. This cycle, like a cosmic heartbeat, has a rhythm of roughly 11 years. During this period, the sun's magnetic field flips, and the number of sunspots fluctuates. This oscillation from periods of high to low sunspot activity is what we refer to as the solar cycle. When the cycle is at its peak, known as solar maximum, the sun is bustling with sunspots. It's like a grand ballroom dance, with sunspots whirling in pairs, honoring their magnetic polarity. But as the cycle transitions towards solar minimum, the dance slows and the sunspots gradually fade away, leading to a quieter sun. Now, you might be wondering, What does this have to do with us here on Earth? Well, the solar cycle influences our space weather and can impact technologies we rely on daily. During a solar maximum, the increased sunspot activity can lead to more solar flares and eruptions of charged particles, which can interfere with satellite communications and power grids. But don't worry, scientists are continuously monitoring these cycles to mitigate potential disruptions. In essence, these sunspots and the solar cycle are key to understanding the sun's magnetic personality. They offer us a lens to observe the sun's magnetic field in action, providing valuable insights into this untamed star's behavior. So the next time you hear about sunspots or the solar cycle, remember, it's all part of the sun's magnetic dance, a dance that resonates throughout our solar system and beyond. Can you imagine 1 billion tons of solar matter being hurled into space at 1,000,000 miles per hour? Now that's a spectacle that truly exemplifies the sun's untamed power. This extraordinary phenomenon is known as a coronal mass ejection, or CME for short. CMEs are giant bubbles of gas threaded with magnetic field lines that are ejected from the sun over the course of several hours. They are born from the sun's magnetic fields, which when twisted and stretched can suddenly snap back and fling out billions of tons of charged particles into space. This isn't just a show of cosmic fireworks, though. Coronal mass ejections are a critical part of space weather, which might sound like an odd term. After all, there's no weather in the vacuum of space, right? Well, not in the way we understand it on Earth. In space, weather refers to the conditions within the sun's outer atmosphere and the solar wind, which can be influenced by these massive ejections. But what does all this mean for us on Earth? Well, when these charged particles reach our planet, they can interact with Earth's magnetic field, causing geomagnetic storms. These storms can lead to some truly stunning displays, like the northern and southern lights, also known as auroras. But it's not all just pretty lights. Strong geomagnetic storms can also interfere with our satellites, power grids, and communication systems. They can even pose a risk to astronauts aboard the International Space Station. CMEs are an active area of research as scientists strive to better understand their triggers and predict their occurrences. This knowledge could help us mitigate their potentially disruptive effects and safeguard our technology-dependent society. So the next time you gaze up at the sun, consider the immense power it holds. Every second, processes are taking place in its fiery depths that can unleash energy equivalent to millions of nuclear bombs. Coronal mass ejections are a prime example of the sun's untamed power, capable of causing spectacular auroras and disrupting technology on Earth. Did you know the sun constantly sends out a stream of particles known as the solar wind? The sun, the heart of our solar system, is a bubbling, boiling sphere of hot plasma, and its energy doesn't just stop at its visible surface. It continuously spews out a stream of charged particles into space, creating what we refer to as the solar wind. This isn't a gentle breeze, but a gust of atomic particles hurtling at speeds of 1,000,000 miles per hour. Now you might be wondering, how does the sun produce this wind? Well, the answer lies in its incredibly hot outermost layer called the corona. Here, temperatures soar to over 1,000,000 degrees Celsius, so hot that the sun's gravity can't hold on to the supercharged particles. As a result, they escape the sun's grip and stream out into space, forming the solar wind. The solar wind is not uniform, though. Sometimes it's a steady breeze, known as the slow solar wind. Other times, it's a gusty gale, called the fast solar wind. These variations can cause dramatic changes in the space environment, leading to space weather events that can interfere with satellites and even power grids here on Earth. One of the most fascinating aspects of the solar wind is its interaction with Earth's magnetic field. When the charged particles of the solar wind reach Earth, they can distort our planet's magnetic field, creating a shock wave known as a bow shock. This interaction forms the magnetosphere, a protective shield that deflects most of the solar wind around our planet. However, some particles do manage to slip through, causing beautiful displays of northern and southern lights, known as auroras. The study of solar winds helps us understand more about our sun, its processes, and its influence on our planet. It's a prime example of how the sun's untamed forces extend far beyond its fiery surface, affecting not just our planet, but the entire solar system. Solar winds, a testament to the sun's ceaseless activity, shape the very nature of space around us. How do we study something as vast and powerful as the sun, you may wonder? The answer lies in the incredible advancements in our telescopes and observatories. These are our eyes into the cosmic world, enabling us to gaze upon the sun's untamed realm. Telescopes, the quintessential tools of astronomers, have undergone a revolutionary evolution since their invention 4 centuries ago. Today's telescopes are not merely lenses and tubes. They are highly advanced apparatuses equipped with cutting-edge technology, capable of capturing stunningly detailed images of the sun. From ground-based solar telescopes to space-based solar observatories, these instruments offer us a ringside view of the sun's dynamic activities. Consider the Daniel K. Inouye Solar Telescope in Maui, Hawaii. This marvel of engineering, with its 4-meter primary mirror, is the largest solar telescope in the world. It allows us to witness the sun's surface in unprecedented detail, unraveling the mysteries of solar phenomena like flares and sunspots. Then there's the Solar Dynamics Observatory, a spacecraft that has been observing the sun since 2010. It gives us an uninterrupted view of our star, scrutinizing its every move, every second of the day. The images and data it provides have revolutionized our understanding of the sun's magnetic field and its dynamic nature. Not to forget the upcoming European Solar Telescope, a next-generation solar telescope that will enable us to probe deeper into the sun's mysteries. With its 4-meter diameter aperture, it will provide the highest resolution images of the sun ever. These are just a few examples of the many telescopes and observatories that keep a constant vigil on our star. They are our silent sentinels, tirelessly monitoring the sun, helping us decode its behavior, and predicting its future activities. Thanks to cutting-edge technology, we're able to peek into the sun's fiery depths and uncover its secrets. These remarkable instruments have brought the sun, an astronomical body of immense power and beauty, within our grasp, enabling us to explore its untamed realm like never before. Ever wonder about the sun's role in our vast universe? This fiery sphere of hot plasma, our sun, is so much more than just a source of light and warmth. It's a celestial powerhouse that influences everything from Earth's climate to the space weather around us. Our sun is a magnetic marvel, emitting a stream of charged particles known as the solar wind. This solar wind interacts with Earth's magnetic field, creating the breathtaking phenomenon we know as the northern and southern lights. More than just a light show, these solar winds can affect our planet's climate, influencing temperature patterns and weather systems. But the sun's influence extends beyond our home planet. Picture the solar system as a vast cosmic ballet, orchestrated by the sun's immense gravitational pull. Planets, asteroids, comets, and even some stars dance to the rhythm set by our sun. It's a cosmic choreography that's been perfected over billions of years. And let's not forget about space weather. Solar flares and coronal mass ejections can cause geomagnetic storms that disrupt satellite communications and power grids here on Earth. They also create hazardous conditions for astronauts and space probes exploring the final frontier. So, keeping a watchful eye on the sun isn't just about scientific curiosity. It's about safeguarding our technological society. Now, expand your perspective beyond our solar system, and you'll find that the sun is but one of hundreds of billions of stars in the Milky Way. Yet, it's a vital part of the cosmic tapestry, contributing to the balance and harmony of our galaxy. From nurturing life on Earth to shaping the cosmic landscape, the sun's influence is truly awe-inspiring. It's a testament to the interconnectedness of the universe, a reminder that we're all part of something much larger than ourselves. So, the next time you bask in the sun's warmth, remember, you're feeling the touch of a star that's profoundly shaping our world and the cosmos beyond. The sun, our nearest star, is a world of untamed forces and captivating phenomena. As we journey through the cosmos, we've uncovered the mysteries of magnetic fields, sunspots, and coronal mass ejections. Our understanding of the sun's solar winds and their profound impact on Earth's climate and space weather has grown significantly. The marvels of advanced telescopes and observatories have opened our eyes to the sun's grandeur, revealing its influence not only on Earth, but across the vast universe. As we venture deeper into the sun's untamed realm, we continue to be intrigued by its raw power and celestial beauty. And this is just the beginning. The field of solar research is an ever-expanding frontier, promising more astonishing revelations in the future. From understanding the sun's life cycle to deciphering its unpredictable behavior, the journey of exploration is far from over. As we continue to explore its untamed realm, the sun never ceases to amaze and inspire us with its raw power and celestial beauty. Thank you for joining us on this incredible journey through the sun's untamed realm. Make sure to subscribe to our channel to stay updated on the latest discoveries and revelations in astronomy.